Today we'll be covering the right-hand grip rule. This will allow us to predict the direction of the magnetic field surrounding that of a current-carrying conductor. But before we do that, let's first have a bit more of an examination on what exactly the phenomenon that we're dealing with is on about. Suppose that we have a current-carrying conductor as shown in blue. We will generate around this current-carrying conductor magnetic field. These magnetic fields will extend along the length, all along the wire, and they'll also be concentric, meaning that it's not just one at that particular height from the bottom. There'll be multiple that are concentric around it and in circles. Now that we have a better idea of what the magnetic field around a current-carrying conductor looks like, we can use our right hand to predict the direction that it will go in. What I want you to imagine is that in your right hand, you are holding a wire. You might not have access to a wire in the exam, so you can also use a pen. After a while, you don't have to use a prop like this, but it can help when you get started. When you perform the right-hand grip rule, your thumb represents the direction of current. So you can imagine that there is current flowing along in the direction that you are pointing your thumb in. I for current. And you can see that when you charge your iPhone, the current should be flowing towards the iPhone this way. Now, that's one component. The only other component are your four fingers. When you should grip around your pen or your wire like so. You'll notice that your fingers curl around the wire. These represent the magnetic field. In fact, I'm going to draw on the direction of the magnetic field. So we can see that the magnetic field, flows this way. So notice how the magnetic field here is going counterclockwise. It starts at my knuckle and flows towards my fingertip as if I'm pointing at someone. So the magnetic field, if my current-carrying conductor, if my cable has a current flowing upwards, is counterclockwise. So all of my fingers represent how there's going to be a counterclockwise magnetic field around my wire. Once we've understood that, now we can begin to go on to some practice problems. Let's have a look at our first example. We can see that there is a cross, which means that we have a wire, a current that's going into the page. So that means that I'm going to be holding my thumb not out of the page, see how this is going into your face, but rather into the page, or into the table for me. Now, I'll be asking myself, which direction do my fingers curl? I can see that my fingers, they'll still be curling from my knuckles towards my fingertips. So if I draw that on again, they're going to be flowing from my knuckles towards my fingertip. So you can see that that's going to be in a clockwise direction now. So the answer is that there's going to be a clockwise magnetic field. Let's have a look at another example now, which is when we have the current flowing up the page. Now, to do that, I'm going to point my thumb up the page to match the direction of the current. Then I'm going to begin to have a look at the direction of the magnetic field. On the left-hand side of the wire, we have the magnetic field. And this magnetic field, if I draw it with more arrows, we can see it's actually coming out like that. And it goes a bit sideways there. So what I can see here is that on the left hand side, I can see that here the magnetic field looks like it's coming out of the page, because it is coming out of the page. On the front of my wire, we can see that the magnetic field is going towards the right. But we don't need to draw that because we're actually taking a cross section through the wire. So I'm going to be looking as if I'm standing right about here. So I'm not. So if I cut off my hand at this point, so I'm not going to see this part of my finger here. I'm only going to see this part. So you can see that my finger will be pointing outwards. On this side, we can see that my finger is definitely pointing into the page, into my table here. And so that should be a cross. So we have a dot on the left and a cross on the right. Which is when we have a wire running towards the right. Because there's the current running towards the right, I will point my thumb, which is the direction of the current, towards the right. Now, I want to see how the magnetic fields go. The magnetic field obviously goes in a circle, but we're going to take a cross section through the middle. So I'm going to take a cross section as if I cut through my fingers in the middle there, and we're going to see what we see. So we can see here, if you look very closely, on the top on top of my finger, on top of my pen, which is where the wire is, you can see that my finger is pointing this way. See how we go from the knuckle towards the fingertip. So in this first stretch of my finger, you can see that it's pointing this way. So we can see on the top, the magnetic field is pointing out of the page. It's pointing into your face. If we then follow this magnetic field, on the front part of the wire, it goes downwards. It's going downwards. And on the bottom part of the wire, the magnetic field is actually going into the page. See how my finger is pointing into my palm? So that means on the bottom, the magnetic field is a cross because it's going into the page. We offer physics, chemistry, and math tutoring. For more insightful explanations like this one, head to tutorgum.com.